Hello, this is Dr. Marion Carroll, and this is our organic biochemistry lecture for pre-nursing students at Dillard University. I believe we're moving on to Chapter 5 or Chapter 5-6, and this is our discussion of functional groups. We just completed a discussion of some of our very common functional groups. Hydrogen, not really a group, but it's important along with hydroxyl. This is a hydroxyl group. These are important in determining the concentration of hydrogen or hydroxyl. In other words, pH. And we define pH as a negative log of the hydrogen ion concentration. And of course, by extension and balance, the pOH is equal to the negative log of the hydroxyl ion concentration. Alright, so by way of review, we talked about Lewis acids and bases. Okay, you need to make sure you review that. Lewis acids are acceptor of electrons, and bases are donators of electrons. So those acceptors are primarily the cations. Cations being those in group 2, group 1, A, and 2A of the periodic table. Alright, and the bases, the Lewis bases, are donators, and you'll find the anions primarily in groups 6A and 7A. Okay, these are negatively charged and these are positively charged elements. So that's important to know, especially when trying to identify an acceptor or a donator of electrons. We talked more extensively about Bronsted acids and bases. And why? Well, because in biochemistry, we are faced with a situation where we're either donating a hydrogen ion, which is the definition of a Bronsted acid, or accepting a hydrogen ion, which is the definition of a Bronsted base. And so these are important to remember because when we talk about acids and bases in biochemistry, we're usually referring to weak acids, which are the same, proton donors, that can act as buffers. Alright, and also weak bases act as buffers. And what's a buffer? Okay, a buffer is it's actually a concentration of a weak acid plus a concentration of its conjugate base that will sustain or will resist changes in pH, or in other words, will sustain a pH at a certain level. So we have both monoprotic, that is, it contains one hydrogen ion that can be donated, or diprotic, which would mean two, okay, or polyprotic, which is greater than 2 hydrogen ions that can be donated and also accepted. So if we were talking about a diprotic Bronsted base, weak base, then we want to describe that as a weak base that's capable of accepting 2 hydrogen ions, or a polyprotic weak base would be capable of accepting more than 2 hydrogen ions. So that's a little bit of the review. You have that in your notes more extensively. I recommend that you take a look at that. So let's look at some other functional groups that are very important, and then we'll go into some more detail about them as we move through the next chapter or two. Amino groups. That consists of a carbonyl and an amine. All right. The amido is what this is referred to, and this is the structure of a peptide bond. Okay, and we talked about what a peptide was. A peptide is a sequence of amino acids. Okay, and amino acids are what? Amino acids are the building blocks of proteins. And I have a list of the 20 common amino acids that I'm going to pass out very shortly. Another important functional group is the acyl group, which consists of a carbonyl and some functional group. R usually is a long chain hydrocarbon. Okay, and we talked about our long chain hydrocarbons, but that's what R would equal, long or short. Okay, R could be a methyl group, or it could be ethyl, 2 carbons, propyl, 3 carbons, butyl, 4 carbons, and so forth. The amino is simply the nitrogen-hydrogen combination, and this happens to be also a Bronsted base, okay, because it can donate this proton, or a Bronsted acid because it can accept proton, become positively charged. Okay, and that's the we find these at the terminal end of peptides or amino acid chains. What are some other functional groups that are very important? Esters. Okay, its general structure contains a carbonyl, oxygen, and one of those R groups. And these are important when we discuss fatty acids shortly. Ethers. All right, ethers contain a double bond. I'm sorry. That's the R, one of those R groups. O, or prime, meaning a different R group. So we have oxygen separating the 2 R groups. And now the amino. Okay, this is actually an intermediate okay, found in metabolism of pyridine. We might talk about forming the I don't think I spelled that correctly. Pyridine, Pyridine. And this is an intermediate important in the formation of certain, let's see, I spelled this wrong, nucleic acids. And another important functional group is our phosphoryl phosphate group. Okay, the phosphate group is highly charged. There are 2 hydroxyls and 1 phosphoryl component here with a double bonded oxygen. Okay, these can be charged, and they lose a proton or gain a proton. So here again, we have a proton donor as the acid and the proton acceptor as the base. Alright, so these are a few of the functional groups that we'll be studying. There are others, and we will study them as we approach those. Okay? I'll talk to you again.